that are answers, extraneous solutions, things like that. So it's a lot of checking. But like I said, the math part of it is really fast. This is one of the easier sections that we do. For example, solve for x.
Can you go back to the slide?
I'm sorry, what's that, Laura?
What's this unit?
Solving radical equations. That's it. So when I go through stuff like this, again, all we have to do is work backwards. Okay? All we have to do is work backwards. So you have to start thinking about undoing your order of operations. So what do you move first? 3. How do you undo square rooting? And now you're in a two-step equation. Add 3, divide by 2. Okay. And then take a second and double check your answer. What's 2 times 14? It's 28. Good luck. What's 28 minus 3? What's the square root of 25? 5. What is 5 plus 3? James, bueno, para su clase de matemáticas es muy importante.
Oh my God. Little wasn't really proud of that, but I
Secretly excited something.
I'm like, that was awesome. You had to remind me of that. Thanks.
Try it right now. Move all the other stuff, or you won't hit it. I told you.
All right, 3 times the quantity. I know. Back to earth. 3 times the quantity x plus 1, all to the 2/3 power, equals 12. Once again, as you start these things out, you're working backwards from the order of operations. Order of operations, please excuse my Darren Sally. Well, the other ones are sad method. What do you do first? Divide by 3. So now you have junk to the 2/3 is 4. Now remember, that exponent is a fractional exponent. We need to get that exponent to turn into a 1. So which means I have to multiply it by something that creates an exponent of 1. What's the reciprocal of 2/3? That's perpendicular slope. What's the reciprocal? 3/2. So what I do is I 3/2 it. Which means you got to remember how to do that in a calculator. Okay? Calculator.
How to wait? You want it.
Exponent of 3/2. How to put a fractional exponent in your calculator? 4 to the alpha y equals 3 over 2.
Oh, the other side.
Okay.
I was doing before.
That's all it is.
Yeah, what is it equal to that number? 8.
Now, if you want to work through the long form, remember 3/2 is the square root of junk cubed. So what's the square root of 4?
2.
And what's 2 cubed?
2 cubed is 8.
8. So all you're really doing is you're pressing a couple buttons. So we wind up with x plus 1 is 8. X is?
9, 7. You are out of it. I got it falling off. What am I getting?
Once again, go back and check your work. Very easy. You just put it back in your calculator. I can type it in literally the way it is. It was 3 parentheses 7 plus 1 to the alpha y equals, oops. Did it equal 12?
Yes, it did.
Like I said, most of you guys are probably very happy right about now because this is not terrible. But wait,
It's gonna get worse.
there's more.
There's always a part where it's easy and then it just gets hard.
Okay? So we have 3 times the 5th root of x plus 1 quantity cubed plus 1 is 25.
Hey, Murphy, you got your calculator over there? Murphy?
Yep. And the button, you got a fraction mark. Yep. And basically, yeah, you guys are right. There's a couple ways of going about this. Obviously, is everybody okay with the fact you have to subtract 1 then divide by 3 right away? That's what you have to do first. So if you do that, you get the 5th root of x plus 1 quantity cubed is 8. And now, at this point, you're right. You have to, in order to undo the 5th root, you have to take it to the 5th power. And then to undo cubing, you'd have to take it to the 1/3 power. You can do this in 2 steps if you want. If I do this first, I'm going to get x plus 1 quantity cubed equals 8 to the 5th. I'm not going to press the button. I just know it's 8 to the 5th. I know it's like 34,000 and change.
32,768.
And now at this point, then I would have to take the 1/3 root or cube root, which basically means I'm just multiplying this one over here by 1/3. So I get x plus 1 is 8 to the 5/3. Now what LeBlanc was saying a second ago, she saw 5th root jump to the 3rd.
Gosh, she's out of control today, I'm telling you.
She saw the jump to the 5th root of jump to the 3rd. That just means it is x plus 1 to the 3/5. If you want to jump right to that, to start the problem, because what's the reciprocal of 3/5? You want to do that? That's fine. Do you have to? No. Okay. Okay. So 8 to the 5/3 is what? 32? No, 31, right?
8 to the 5 over 3.
Oh, it is 32, yeah. Sorry.
Minus 1.
So the answer is 31. You okay with that? Now again, you go back and check it. No, usually, yeah, actually, right about now. Yes, ma'am.
Alright, so if you take like 8 to the 5th, couldn't you just like get the answer for that and then
Yeah.
like go to the x plus 1 to the 3rd and you just take like
Cube root?
cube root, so
Yeah.
it's like okay.
Like I said, hey guys, come on. There's not much here, and that's fine. What I'm doing there by working with the exponents and you're working with the fractional ones, it's just faster.
Yeah.
That's all. And there's no, I'm not going to tell you one way is better than another, because there are multiple ways to solve these things. It doesn't matter.
Okay.
Okay? And it worked, right? We didn't have to worry about extraneous solutions.
What's that?
An answer that's not an answer, but it's an answer.
Oh, great.
So now, we add more steps.
I would have left last year.
So I have the square root of x plus 7, all subtract 5, is x. What's that? No. So, in order for us to be able to solve for x here, we got to get rid of the root. So we have to get to the root of the problem. Not humorous.
Wow. Good one.
Be okay there?
Yes.
So now, how do you undo square roots? Square it. So what you're going to wind up having to do here is you're going to create trinomials, which means we have to factor. That's all. Oh no. Do not kill puppies, please. Please,
Ooh, I
please,
did.
please.
I killed a puppy.
X squared plus
There goes all my wicked.
Please stop. I'm getting the twitch.
stop killing puppies.
Are you killing puppies?
No, you said that. He really got me this right. She's like, ew.
Is that redundant?
I killed a dead puppy.
No.
Oh my god, I did.
While you're back there, right after we did it, throw him.
So now we're back to this point where we're. Come on, guys. Now we're at the point where we have to set aside equal to 0, like we've done before. Move the x plus 7 over to the right. We're going to get 0 is x squared, a 9x, and an 18. What times what's 18 you add together to get 9? 6 and 3. Very good. So you have terms x plus 6, x plus 3, which gives you zeros at -6 and -3, which means we have to check our work. Our original problem. Our original problem was this. We substitute in. What is -6 plus 7? Square root of 1. 1. 1 minus 5 is -4. Did -6 work? -6 is what we call an extraneous solution. It's an answer, but it's not the answer.
So we cross it off.
Then I go and check -3. What's -3 plus 7? Square root of 4. 2. 2 minus 5 is -3. Did -3 work? Yes. That's what happens a lot of times. Come on, guys, really? That's what happens a lot of times when you have factoring ones. You might get one answer to work, two answers to work, no answers work. It is possible, okay?
What are you looking for?
Basically what you're looking at here is where's the intersection of these two graphs? Where do these two intersect each other? Where does the square root of x plus 7 subtract 5 equal x? So if you graph this in your calculator, if I threw that in my calculator, these two intersect at -3. That's all it is. Okay. Very exciting. Same deal. Same deal. It's problem solving. So this one, again, what you want to be able to do is you want to be able to set it up so you can square both sides. So, in doing so, move the root x over. we get the square root of 2x plus 1 is 1 plus root x. So now you have to square both sides. The square root of junk squared is junk. The other one you have to FOIL out. 1 plus 2x, 2 root x, plus x. Okay. What's that? Set aside equal to 0. So I'm going to move everything from the right-hand side to the left. Okay? So I'm going to subtract 1, subtract the 2 root x, and subtract x. Excuse me. So then I'm going to get x minus 2 root x, 0. Really not getting me anywhere, is it? So, set it and move it back. Bless you. Square both sides again. You're keeping it balanced by doing this. If you square both sides, you get x squared. And what's 2 root x quantity squared? 4x. 4x, good. Now set aside equal to 0. Set aside, you cannot divide by x here because you eliminated a 0. When you're factoring stuff to find possible zeros, you cannot divide out by a GCF. It eliminates a possible factor. So we subtract it back over. No. You have a GCF problem. Take out x. Because you have 2 zeros. You have one at 0, 4. Yeah, Larry?
Okay, you lost me at the part when you
Here?
Yep, there.
Okay.
Yeah, how'd you do that?
So when we were at this point here, when we start to think about it, we have to solve for x. Usually what you do, you set one side equal to 0 to see what you have. So I had a larger value of x on this side, so I subtracted everything over. So then the 1's dropped out, and I wound up with 2x minus x was 1x minus 2 root x, and that was 0. This didn't get me anywhere because I can't find GCFs when you have square roots. So knowing that if I wanted to keep this balanced and get rid of the radical, that was called, that's why I just moved it back real quick and squared both sides. That's how you have to set this one up. Okay? Yes, ma'am?
So when you check it, is there a possibility that both answers work or the zeros on
Yeah. Yep. So when you go back to check this, it's all the way back down here. We had this as our original problem. What's 2 times 0? 0. What's 0 plus 1? 1. What's the square root of 1? What's 1 minus 0? 1. So did 0 work? Yes.
So does that mean that 4 can't work?
It could or it could not. We don't know. What's 4 times 2? What's 8 plus 1? Square root of 9. 3. So this part's 3. What's the square root of 4? What's 3 minus 2? Did it work? They both work. It is possible we're not taking the square root over an equal sign, we're just taking the square root of the value. Okay? So in this case here, they both work. Yes, ma'am? Yep. No, that's it. Very similar. Try that one. Very, very similar to what we just did. Okay.
I get 2x. And I know.
Yes, it is. Yes, it does. Good job, Oh, wow. That's a lot of canceling out.
I mean, you go back and look at this. In order for that to even work, if you just start thinking about, if you start thinking about just your basic, perfect squares and stuff. It has to be 0. No?
Yep.
I'm trying to think if there's anything else that'll mess you up. I think everything else is very, really no craziness. Oh, I know. Maybe this one. I did this 1 second hour, and they're all kind of like, oh, great. Last one. Why not?
What are you thinking about? That's what I don't remember. What?
The answer is 6.
I wish I could do that.
There we go. So you have the 5th root of a bunch of junk equaling x. So we have a 5th root of 4x cubed plus x squared minus 4 is x, which means we have to undo the nth root.
Wait, is that line supposed to be there?
No, it just snapped in. So how do you undo an nth root? Raise it to the n. Well, what's our n? 5. So we put everything to the 5th power on both sides. So now you have 4x cubed, x squared minus 4 is x to the 5th. Which means I have to set one side equal to 0. Which side am I going to set to 0?
Are you sure, maybe?
Move everything from the left to the right. So we get 0, x to the 5th, 4x minus 4x cubed minus x squared plus 4.
How do you know these are?
You always want to deal with your first term to be positive, and we go in descending order, so you just figure out which one is the highest degree and work off of that. So now, at this point, there's a couple of things you can do. You can use synthetic division if you want. Or, come on, guys, come on. You can use synthetic division if you want. It works real fast if you want to go that route. Or, 4 terms, isn't it? Always check and see if you can group it. GCF of x cubed, x squared minus 4. GCF negative 1, x squared minus 4. So now you have, put this up over here, I have x cubed minus 1 and x squared minus 4. The x squared minus 4 is easy to get the zeros, plus and minus 2. The other one's a little bit tricky. It is going to be just 1, but remember, this is a difference of cubes. So if you set it through, that means it's x minus 1, x squared plus x plus 1. But don't get too much in the habit of that, because if it's a 4th root or a square root, if you do that, you can wind up eliminating value. You just got to be careful with it, that's all. I mean, sometimes it works out, sometimes it won't. Because here, remember when we did this before, we always got non-real answers for the cube root stuff? So that's kind of the same deal. So you're right, we're going to have a 0 at 1, and then plus or minus 2. So you have 3 of them, just to double check to see if it works. This is a difference of cubes. So when we do difference of cubes, there's a pattern. And that was the pattern. Okay? That's about as goofy as any of this stuff can get, to be honest with you. Everything else is pretty straightforward. I didn't do it. I swear to you. Yes. Because what's the cube root of 1? Negative, or this would be positive. I already posted the homework. So it's on the calendar. Did I not have the calendar? What I did, no, it's in the book. It's actually in the book itself. So you guys have to do the 15 clicks to open the book. I would highly recommend that you screenshot it. Yes, ma'am. It's on the calendar.
Is this a new book?
Now, well, I'm gone tomorrow from the math team. Hey, guess what you're going to do tomorrow in class? The odds. So you might as well just do it all at the same time. You got 2 days to do it. What's that?
Okay, what's the number?
No, we're just by ourselves.
Because then tomorrow.
So we can just have it all on one paper.
No, Joseph is sub.
So basically, ladies and gentlemen, basically what it works out to be is yes, over the course of the next 2 days, you have 26 to 60 to do. What I was just doing was just setting it up so you can just do halves and halves. Yes, ma'am. Yes, ma'am. Yep. I know. You have the bus right there. You got all day there. You know, it's fun. Forgot how to get to the bus?
I'm just kidding.
Tuesday and Wednesday to do 26 through 60.
No, we just have tomorrow.
Over the course of the next 2 days, you have those 2 assignments.
Today and tomorrow.
No. Try and keep up, Artie.
Joseph is already.
Why is it two separate assignments?
Hey, we've done that before. Sarah for Kyle rather than Kyle. There was no subject speech one day instead of like,
So remember, guys, just so you, in case you forgot, because that never happens. In order to get to the book, you click on the regular tab, and then you have to go to the Pearson website. And then it's your 15 clicks to open the book. And it redirects you all around. What page did I say it was? 296 or something like that? I was close.
Like, no better way to do this.
It's not PDF'd. Believe me, there might be a good chance that I might PDF the book soon. I gotta take a book and cut the binding in.
Do we go to, we click on that, we don't click on Math XL, do we?
No.
Click on the other one?
Yep. I'm still clicking on all the other clicks I have to get to open the book.
And we go
Your username and stuff like that should be the same as everything else.
do we go to programs?
Easy, Hoppenworth. So then you get to this. 15 clicks of annoyance. No, but when we pass half papers, we probably will. We'll find out.
Question.
Okay. I wasn't there.